Welcome back. In this installment, we will look at the single responsibility principle with some code examples in Java. Let's dive in. Welcome back. In this practice session, we'll take some code that violates the SRP and see how we can first recognize the issue and then how we can fix it by refactoring the code. It is important to develop an eye for solid principle. So these simple exercises provide a way for you to get familiar with solid concepts from a perspective of actual code examples. Here we have a very simple class, user settings, that violates the SRP but seems reasonable at first glance. It is a simple class that aggregates a user, and then when a user wants to change their settings, like an email for example, it has the logic implementation to see if the user has the access rights to do that. So this seems pretty innocent, but this class does violate the SRP. Before we refactor the code, let me give you some hints so that you can try to figure it out yourself first. Here are the hints. Identify different responsibilities in the given code. So have a look at this code and list the responsibilities. Create a separate class for each responsibility and ensure that each class has only one reason to change. In other words, it takes care of one aspect of the system. If you want to give it a go and think about it yourself, then pause the video. Otherwise, let's have a look at the solution. Here is the refactored code. Have a look at it. The original code violates the single responsibility principle because the user settings class had more than one responsibility. It was managing user settings, like for example changing the email, but it was also handling and implementing user access rights, which was the check access method. That makes the class much harder to maintain and modify in the future because one class was actually implementing a number of different elements in the system. In the refactored solution, we have separated the responsibilities into two different classes. We have the user settings and we have the security service. The user settings class is solely responsible for user settings, and the security service class handles security-related functionalities such as access rights. This adheres to SRP, making each class responsible for just one aspect of the system. Notice also that we have an example here of dependency injection in the form of injecting the security service into the user settings class through the constructor. The most important observation here, though, is that the two classes are independent, and any changes specific to each class's responsibility is confined to its own class. Now, this makes it so much easier for both testing and maintenance. So if at some point we want to change how the access rights are actually implemented, we go to one class, which is the security service class. We don't go to user settings. All right, so this is it for this particular little practice session. I'm going to see you in the next one. Do have a look at the examples of SRP in other languages such as Python and Dart in this playlist, as they will give you more exposure to this principle. In the next installments, we'll be looking at the open-close principle. See you soon. Don't forget to hit the subscribe button, give us a thumbs up, and ring the bell to get notified about our latest content. Thanks for watching.